Now moving on to the next part of this Introduction to Programming 1 course, data types. There are a couple of main data types used. The first being numbers, which are pretty much self-explanatory. And what's important to know about numbers is that they have distinct properties that other types of data don't have. Of course, they describe a numerical value. They can be used for calculations, or they can be used to count or keep track of a quantity. And there's a distinction made between a number and a string that happens to contain a number. This is the example given, the number 20 in the text. I'm 20 years old. Though the number of 20 is obviously used in this string, the computer still performs an operation on the first piece of data, namely the data being a string, not on the second, with the second being the quantity of 20. So here's a visual given of a scale of a baseball diamond, 1 meter being represented here. Obviously, you can increase it to the next power 1, 10 to the 1, which is just 10 meters, and so forth. So this is just a visual representation of what how computers can process numbers and essentially keep track of quantity. 1 million, 10 million, and so forth. Next type of data type we'll be covering are strings. Just as the distinction had been made prior with numbers being represented differently than strings. Strings are essentially just sequences of characters, albeit arbitrary ones, letters, spaces, numbers, or symbols. Really anything can be used to represent or be a string, but usually it's a string usually contains actual legible text or speech. And of course, the syntax used to represent strings are single quotations or sometimes also double quotations. And here are a couple of different use cases for strings or why strings are used or in what ways they are used. Displaying data, adding or removing text, the modification of characters, or just to display text in an interface to the user. Strings are very similar to other data types, but the difference is that they do not contain actual numerical quantities, as in the case of a number, and they don't contain logical properties, as in the case of a Boolean. So those are the kind of differences between the three data types: numbers, strings, and Booleans. This is a visual example of how strings are essentially units of information that are strung together, hence the name string, very similar to a string on a necklace or the beads of a string on a necklace. Which each element of the string made up of discrete letters. Thirdly, the final type of data covered in this module is the Boolean. Whereas numbers represent numerical values and strings represent essentially characters in sequence, Boolean values represent or contain properties of logic, whether that logic is true or false. So a Boolean can only contain, unlike numbers or strings, can only contain values that are, like I just said, true or false. True or false. What are they used for? What are Booleans used for? Well, as this property would imply, it helps determine whether something is true or false. So it's used, computers use it to check for validity, essentially. For example, if you want to know whether, if they wanted to test whether something such as a meme was viral, you could run code that contains Boolean properties to see if this meme was viewed with the condition that for it to be truly viral, it must have been viewed at least 50 million times in less than a week. So those are the conditions given. If both those conditions are satisfied, then the Boolean for this example would be true. If not, it would be false. Hence, it would be reasonable to presume that Booleans are used to, computers use Booleans to essentially make decisions. An example is given that if computer's checking, if you received an email, it's going to have a Boolean that checks whether the email is new. And if it's new, it's going to display it to the top of the inbox. So it's deciding where to place the email, the new email. Also, another metaphor for Booleans is that they act as binary opposites, very similar to a light switch being either on or off, with on being compared to, or being represented as yes, and off being represented as no. Sometimes even the numbers 1 and 0 are used for on and off, respectively. So as you can see, this is an example of a Boolean. Variable lights on being false. The lights are on in the house. But when I toggle this switch, lights on now becomes true. And in fact, the result is that the lights are on in the house, as per the Boolean lights on being true. In summary, the three main data types we covered were numbers, strings, and Booleans, with an example of each being displayed here in the console. My number variable equals 150, which is a number. My string variable equals hello in single quotations, which is a string. And finally, my bool variable equals true, which is a Boolean. So as we can see here in this function area, suppose we wanted to run a square function. Click transmit. Our output, 22,500, is simply the square of the number, my number, variable 150. In other words, 150 times itself, 150 is equal to the output, 22,500. because it's 150 squared. If we wanted to run the capitalized function, our output is hello, which is a string. Just a series of text that is typically legible to a user. Finally, if we wanted to run evaluate, the evaluate function, our output in the console would be yes, because as shown here, the myBool Boolean variable is true, which corresponds to the output of yes. And all three of these variables are considered to be primitive forms of data or fundamental to almost every programming or coding language. We're going to retake the quiz. So because this variable is equal to true, we know fundamentally it has to be a Boolean. Next. Data types are important because they identify different information used in programs, as we just discussed. Next. The three main primitive data types include, we have strings, numbers, and booleans. We're going to evaluate whether this is true or false. My favorite show is equal to 24. Notice the syntax of single quotations. This is indicative of a string, hence it's true. And why are strings called strings? Because they represent a sequence of characters or symbols, very similar to beads strung together in a necklace. And that wraps up this data types module in the Introduction to Programming 1 course.